In this video, we're hoping to connect what we're learning this week with what we learned last week. So last week, we learned to differentiate between linear and exponential. And so I'm looking at a graph of the milligrams of ibuprofen in the body. And what I notice about this graph is that there is a curve. And that curve is my indicator that this would be an exponential function. So this week, our goal was to be able to write the exponential, use it on the calculator, and then to solve it for time. So connecting with what we did last week, I want to write an exponential for this problem. Because it's not a word problem, I'm going to need to be able to figure out the rate of change. And so I do that because change is not constant. I have to do that by percent. And so we know that percent change is the new minus the old divided by the old. And we talked about last week that we don't want to multiply by 100 because we actually want to use the decimal. So the new value that I have here is 420 minus the old value of 600 and then divided by the old value of 600. And so I have to go to my calculator for that. So 420 minus 600 is going to give me 180. And then I'll divide that by 600. And I get negative 0.3. Now, this week, as opposed to last week, we have some models to work with. And when I think about this 0.3, what I'm really seeing here, if I was thinking about this in a word problem, is that the negative is telling me that it is going to decrease. The 0.3 would be the same as 30%. So decrease by 30%. And I got my numbers an hour apart on the graph, so that is per hour. And so this means that of the models that I have, based on what I found here as the percent change, that I want to use the drug breakdown model. And so in my notes, and the notes that I will get to do my quiz, I have the drug breakdown model, and we have starting amount 1 plus r to the t power, and plugging all my numbers in here. So this will give me starting amount of 600, because that's when the time was 0. I'm reading that from the graph. In the parentheses, I know that my rate is a negative 0.3, so I'm doing 1 minus 0.3. And if I do that on my calculator, that gives me a 0.7. So I'm doing all that math ahead of time so that I have a formula as simplified as possible, exponent of t. And so we met our first outcome of this week, which is to be able to write the exponential equation. And we did that from data rather than from a word problem. So that one's done. Next, we're to calculate the ibuprofen in the body at 6 hours. So the 6 hours is the time. It's going to go into my formula for the t. So in my calculator, I'm going to type 600 times 0.7, use that caret key to the 6, and give me a moment to type. So 600 times 0.7, caret key 6, and I get answer of 70.5894 if I round to a whole unit, 71 units of ibuprofen remaining at 6 hours in. And lastly, we're asked, when were there 250 milligrams of ibuprofen in the body? So the 250 milligrams is an amount that's remaining. That's going to go into my formula for P of T. So 250 is equal to 600 times 0.7 to the t power, and I don't know t. Now, we've talked about all throughout the lesson today that when we don't know t, that's our chance to use Desmos, and we want to split this into two equations. So my one equation is y equals 250. My other equation is the other half here, which would be y equals 600 times 0.7 in Desmos, like 6 and y. So I'll put x there for my unknown. So I'm going to pull Desmos over here to my screen and type in my first equation. So this is y equals 250. And then type in my second equation. So this is y equals 600 times 0.7 to the x power. I don't see anything now, but I know that these are to produce a curve for the exponential. We actually had the curve on our other graph. And to produce a line for the y equals 250. So I'm going to use the minus to zoom out. So there's my curve starting. And then I'm guessing that this is going to happen before very long. And I tell you that because I can see right here that this should happen between 2 and 3 hours because I have this data point. So 250 is between the 2 and the 3 hour mark. So on Desmos, I could continue to use the negative to continue to zoom out, but I also can click and drag. So I'm going to click with my mouse and drag my graph down. Come to the top, click with my mouse, drag my graph down again. I find that this is actually easier to do on my touch screen because I can just scroll, but if you don't have a touch screen, I'm really going up to 250. That is what I would like to see. So I'm getting close here. You can see 230, and I'm just clicking and dragging, and here I see my answer. So I click near there, and I get at 2.455. So if I would round at 2.5 hours, which is very much what we guessed from the graph that we have. So at 2.455 hours. So answer here, when will this happen? This will happen when time equals 2.455 hours. And so in this, we met our other two outcomes for the week. So the first outcome we checked off was to write our equation. Second outcome is to use the calculator. And so we did that. And our third outcome was to solve for time. And we said we could do that using a graph or a logarithm. And we definitely did that using a graph rather than doing the by hand algebra. I did want to go back to the graph a moment, just because you may not have been comfortable with the way that I scrolled. So I'm going to hit home, resetting the problem to how we typed it in, hitting the minus key to zoom out. You notice that I just keep hitting this to keep zooming out. So I hit that like 4 or 5 times, and coming up here, I can click and get that same answer. So I did not have to do the dragging that I did. For me, I did that because I knew that my answer was between 2 and 3 hours from the other graph, whereas here I see that I'm seeing like how much ibuprofen is there 300 hours out, and that doesn't seem realistic that I'm going to look at like you take an ibuprofen and then 300 hours later. But I get the same answer, and so we can just use these built-in zoom features, or we can change things by clicking and dragging. So I hope that this helps connect the 2 weeks, one that we studied from the graph, figuring out the equation and identifying that a curve is exponential, and then connecting that to the models that we had this week, specifically the drug breakdown model, and connecting that to our other outcomes then, that once we have that equation, which we call a model, we can do so much with that equation.